Assalamu alaikum wa rahmatullah. In our last lecture, we introduced how to describe your data in frequency tables and graphs. Mainly, we introduced 4 points. We said how we can present the qualitative data in frequency tables, how we can present the frequency table in some graphs, mainly the bar chart and the pie chart. And then we said how to organize or present your quantitative data in frequency distributions, and how to present the frequency distribution in some graphs, mainly histograms, the polygon, and the OGIF or cumulative frequency polygon. So that what we introduced already in the last lecture. Now what I will do, I will introduce applications for the same topics. So now I will have 2 examples. One example for the qualitative data, how to present the qualitative data in the frequency table, and then in the graphs, mainly the bar chart. And I will introduce the quantitative data, one example for the quantitative data, and how to present that in the frequency distribution and introduce that in the histogram. And then I will discuss how we can use the histogram, how we can introduce the histogram to describe the distribution in your data. Okay, so now we can share the materials, the examples for our today. So now in summary, I summarized again what is the meaning of the raw data, the frequency distribution, the relative frequency, the percentage frequency, and the cumulative frequency, as we discussed in the last lecture. So in general, for the qualitative data, we have frequency table, and we can present 2 graphs, the bar chart for each level or for each value. For the qualitative variable, you have 1 bar, we name that the bar chart, or a pie chart based on the relative frequency values. Second, for the quantitative data, if the variable is numeric and you can put that variable in some classes or intervals, then we have the graphs, we have a histogram, and you have to know the comparison or difference between the bar chart and the histogram, and then we can introduce a polygon and the OGIF. OGIF, the cumulative frequency plot. The cumulative frequency plot, we name that as the OGIF in some time. So directly now I will start for the applications. So example 1 for the qualitative data. So assuming now in example 1 we have we have 20 students, and each one of these students, we ask him about his evaluation for the instructor. So now we have one table. In that table we have the 20 values, the first value, second value, and so on. So what these values means, what these values actually mean, these values mean you have the evaluation of the instructor for the 20 students. So now the first student evaluating the instructor to be AA, which means above average. So now the evaluation of students for the instructor is our variable, and that variable is qualitative, and that variable takes only 1 of 5 levels or 5 values. The highest level, excellent, E; second level, above average, AA; and average, A; below average, B; and poor, P. So now using notations, so first student evaluating the instructor to be above average, second one below average, third average, and so on. So now I have 20 values for each student. We have 1 value for his evaluation for the instructor. So now before reading the questions, what is the variable under study? The evaluation of students for the instructor. Second, that variable is qualitative or quantitative? Is it qualitative because the values of that variable is non-numeric, like excellent, above average, and so on. Okay, so now in that case we can construct the frequency table. Mainly we can say frequency table. Sometimes we say frequency table or frequency distribution in the same meaning, but I prefer to say now question A, construct the frequency table, so that we can write that as a table. Okay, because mostly we are using frequency table for the qualitative data and frequency distribution for the quantitative data. So question 1, construct the frequency table. So how I can construct the frequency table? Very simply, I will count for each level how many values we have. So now I have 5 levels. So now we can put that in one table. So that the frequency table now. So you have the first column, the level or the category. So for the category, I mean the values of the variable that I have. So now I have highest level E, double A, B, and P. And then the frequency means the count. So now in that table, count how many we have excellent. So that is 1, 2, 3, 4, 5, and have 6. So you have 6 values for the level excellent. Second, above average, you can count the same way. So you have 1, 2, 3, 4, 5. So you have 5 values for the category double A. And then for value A, average, just you can count. So you have 1, 2, and 3. So you have 3 values for A. And B, just you can count. B is 1, 2, and 3, 4. So you have 4 values for the evaluation to be below average. The last one, actually LP. So for LP, just you can count, you can find only remaining 2 values. That's 1 and 2. And then to make sure that you have the correct frequency values, just adding them up, you'll find that equal 20. So that's the frequency table, and that's the answer for question A. The question B asking you calculate the relative frequencies and percentage of all the categories. So that means relative frequency, each value in the frequency relative to the total, and the percent frequency, just the relative frequency times 100. So now we can add a new column. So in the same table, you don't need to create another table. So in the same table, you can create the relative frequency values, and you can create the, so that assuming that relative frequency, and then you can create a percent frequency, just a percent frequency equal relative frequency times 100. So now the question, what is the difference between a relative frequency and a percentage frequency? There is no difference in the information that you have, just the form that you are presenting your data. You are presenting your data as ratio from 0 to 1, or you are presenting your data as percentage out of 100. So that's the difference actually. So just the relative frequency first, and then you can find the percent frequency. Relative frequency, each value relative to total. So the value 6 divided by 20, then you'll find that equal 0.3 or 0.30. Okay, that 0.3 or 0.30. 5 over 20, that will find that equal 0.25. Using your calculator, find that out. And then 3, that equal 0.15. I'm using actually a mouse, so it's okay. And then 4 equal 0.20. The last one 2.10. Then adding them up, you'll find the total for that equal 1, because sum of the relative values equal 1, because you have sum equal 20 over 20, so that actually normally equal 1. A relative frequency, just percentage frequency percentage frequency equal a relative frequency times 100. So now 0.30 times 100 equal 30. So just you have the values out n%, so that 30%, and so on for all the values that you have. So that 30%, 25%, and so on. So actually I have the table for you. So that the table for the relative frequency and percent frequency. So just calculate it in the same way as I'm showing you actually. So that's the answer for question B. So now the frequency table, just to count how many values you have for each level, and then relative frequency, each value relative to a total or divided by total, and so on. So now we answered question A and question B, that very simply. So question C, based on the relative frequency and based on the percentage frequency and based on the values of the frequency itself, you can ask some questions and you can answer them. So in question C, just asking about the percent, but anyway, you can ask you using how many, or using what percent, or using what is the probability. So now I will ask some questions and then we can answer, and we can cover that using point C. So if I ask you how many students evaluating the instructor to be excellent, so if I'm saying how many, so just you can use the frequency values. So how many students evaluating the instructor to be excellent, just we can check that for E you have 6 values. So now the answer equal, we have 6 students evaluating the instructor to be excellent. But I can extend the question in the same way as we have in the probability. Okay, if you remember in the probability topic in applied mathematics, we ask questions like at least and at most and so on. So in the same way, so now if I ask you how many students evaluating the instructor to be at least average, so how many students evaluating the instructor to be at least average. So at least average means معناها على الأقل average, يبقى includes average and above average and E excellent. خلاص يبقى these actually 3 values now is mutually exclusive events. And then adding them up to answer the question how many students evaluating the instructor to be at least average. So sum of these 3 values, that will give you the answer. So that equal 14. In the same way, if I ask you how many students evaluating the instructor to be at most average. At most average means على الأكثر average, يبقى includes these 3 levels A, B and P. يبقى the answer for that equation equal 3 plus 4 plus 2, so that equal 9. Okay, so please you have to be careful. So if I can ask many questions using how many, using what is the probability, using what percent. So if the question how many, then you are using the frequency to answer these questions. If the question using what is the probability, then using a relative frequency to answer these questions. If the question what percent, then using a percent frequency. So now the same questions, if I ask you what is the probability that the students evaluating the instructor to be at least average? At least average means A, double A and E, and the question what is the probability, then you have to add these 3 values. Okay, now we return to the question C to answer question C. So question C saying that what percentage of these students rank this instructor as excellent or above average. معناها بالعربي ما هي نسبة الطلبة اللي بيقيموا الانستراكتور بيكون excellent أو above average. كلمة or هنا union يبقى excellent or above average and have the question percent. يبقى to answer that question that E excellent or above average and the question using the percent, so that the answer for the question 30% plus 25%, that equal 55%, and that's the answer for question C. So in the same way, we can ask many questions in that direction, using how many, what percent, what is the probability, and so on. Okay, so now we answered the question C, and we covered all the points related to question C. Now we can start how I can visualize the frequency table. As I said before, we can visualize the frequency table using a bar chart or using a pie chart. A bar chart, for each level you have 1 bar and the height for that bar equal to the frequency or a relative frequency according to the question. And in pie chart, just you have 1 circle, includes all the levels, and that circle divided into some parts, and the size for each part equal to in somehow a relative frequency for that level. So I will explain for you in details how to plot a bar chart. So now a bar chart, very simply you have x-axis and y-axis. So now I can, for the bar chart we need first the x-axis that includes all the levels that you have for the variable, and on y-axis it will be according to the question, can be frequency, can be relative frequency, can be percent frequency based on the question. So now draw a bar graph for the relative frequency. Even now I'm putting on the y-axis a relative frequency, not a frequency. So now put first levels. So levels starting from P and then B and then A and so on. So now you can order or rank the levels because that is actually ordinal data. Okay, so that the first one is P, second one B, third A, that one is B, and then A, and then double A, and the last level E. The y-axis includes a relative frequency. So now for the relative frequency, just you can check the minimum value and the maximum value and try to put that on the y-axis. You have to make the y-axis as a scale includes all the values. So now relative frequency, look at all the values. The minimum value 0.1, the maximum 0.3. So you can fix the scale as 0.1, 1 by 1, the distance, the unit of the distance can be 0.1 or can be 0.05 whatever, but you have to fix that as a scale. يعني عايزين نحط على الواي اكسس relative frequency values، ممكن تمشي 0.1 0.2 0.3 and so on، او تمشي ب 0.05 يعني 5% 5% as you like. I will do that as 0.05 الديستنس، هخلي الفرق بين كل نقطة ونقطة اللي هو 5 من 100. يعني أول value دي 0 assume that 0 then 0.05 that value 0.05 that the first value equal distance second value 0.10 and then 0.15 approximated assuming equal distance 0.15 and then 0.20 and then 0.25 the last one 0.30. طبعا I'm trying to make it equal distance، يعني بحاول اخلي المسافات متساوية بشكل او باخر. Okay, that ال y axis includes the relative frequency، كان اكبر قيمة maximum 0.30 فانا عملته 0.30 maximum. Now for each level we have one bar and the height for that bar equal to a relative frequency. يعني كل level او كل category هحط له بار، والبار ده هيبقى ليه ارتفاع بيساوي ال relative frequency value. يعني ال P هنا ال P that has relative frequency equal 0.10، يعني هنعمل 1 بار هنا وتبقى الارتفاع بتاعه ايه 0.10، يبقى اهو 1 بار والهايت for that bar approximated. طبعا بحاول يعني اخليه مضبوط شويه، انا طبعا بستخدم الماوس فعشان كده احيانا ما تبقاش مضبوطه قوي. that ال A for ال P and then for ال B has to be 0.20، يبقى second bar you have separate bars actually، يعني في بار لكل ليفل وفي بينهم مسافه. okay that is second level. the third level اللي هو ال A 0.15 that 0.15 and then double A 0.25 that 0.25 approximated, and the last one E هو 0.30 maximum level. That how to visualize your data in bar chart. Why we are visualizing our data using a bar chart? To make it easy to compare between levels and you can see distribution of the levels that you have. So now what you can see, now by one look I can say that the highest frequency for the excellent and the lowest frequency for the P، يبقى أعلى مستوى لتقييم الطلبة كان المستوى E وكان أقل مستوى هو ال P. خلاص يبقى البار chart giving you the easy way, making it easy for you to compare، يعني simplifying the idea that you can compare between the levels that you have. يبقى that in general why we need the bar chart to simplify the comparison between the levels and you can see a distribution of the values that you have, and that for the qualitative data. In the same way you can present the qualitative data or frequency table in one pie or pie chart. So pie chart, and somehow you have one circle, we name it as a pie, and that circle you can divide it according to levels that you have, but each level the size of the part for each level equal to a percent or a relative frequency. يعني الباي chart هتقسم الدايره دي الى اجزاء. هنا عندي how many levels؟ عندي 5 levels، يبقى هنقسم ده الى ال 5 levels، يبقى اعلى size of each part or each slice in that pie equal to a relative frequency. طبعا هنا we know that in the pie has 360 degrees, and then angle you can do that actually the angle for each part according to relative frequency. Like anyway, the most used a graph for the qualitative data is a bar chart because very easy for you to compare, but for the pie chart you have similar parts, then you will not identify which one is higher the other. This is why we prefer most to use a bar chart, but still you have to know that we have another graph, we name it the pie chart. We can use some softwares to find it out, and I will give you that in the notes. You'll find a bar chart given for you and you have a pie chart given for you, but you have to know that that is P, B, A, double A, and the last one is E, so that is missing. So you have to know that the last bar for E. Okay, and that's how to plot the pie chart. So what you can observe, one pie includes 5 parts, the highest one for E and second one for A. But what you can see, E and A very close parts. So from a pie chart we cannot actually differentiate which one is higher than the other. Okay, but for the bar chart it's easy to say that E is higher than double A. So that's the point I need to say. يعني من رسمة البار تشارت هيبقى سهل جدا المقارنة وتعرف تقول مين أعلى بار، لكن في حالة الباي تشارت لما بيكونوا قريبين من بعض زي الإي والدبل إي زي ما أنت شايف كده هيبقى صعب عليك تحدد مين أكبر، هل هم فعلا متساويين ولا فيهم واحد أكبر ولو بشكل بسيط عن التاني، وده اللي بيخلي الباي تشارت أحيانا استخدامها أقل من البار تشارت. يبقى البار تشارت هو الأكثر استخداما لأنه بيساعدك على المقارنة بشكل أسهل وبيكون في دقة في النمبرز that you have. Okay, so anyway, now we've finalized how to visualize the qualitative data, how to present the qualitative data in frequency table, and how we can visualize that, how we can find relative frequency, percentage frequency, and use them to answer some questions. Now we can move to how we can present the quantitative data in frequency distribution, and how to visualize that using histogram and using some other graphs. Okay, so now before starting answer that example. So now it's given for you. You have a daily production of computers for 30 days. So that means in that table, the first value that the production of computers in the first day, you have 24 computers produced in the first day. The second, you have 32 computers produced in the second day, and so on for all of that, and so on for all of that. يعني عايز اقول المثال ده بيديني انتاج الكمبيوترز اليومي خلال 30 يوم. اول يوم كان فيه 24 كمبيوترز produced and so on لغايه اخر يوم كان فيه 27 كمبيوترز produced. طبعا now I need to summarize this data in one frequency table to be useful, simple and useful frequency distribution. يبقى the frequency table in that case we can name it as a frequency distribution for the quantitative data. Now the question A, I'm asking you construct a frequency distribution using the classes, and I'm giving you the classes, but actually I will answer the question A using in 2 ways. I will answer the question A into 2 ways. The first way using the classes that I'm giving for you, and the second way assuming you don't have the classes, how to construct the frequency table. Okay, so now I need to answer that question A into 2 ways. So now the question, what is the variable under study? The variable under study, the production or the daily production of computers. So that our variable, the daily production of computers for 30 days, that our variable is a quantitative because you have numeric values. Now how I can construct or how I can present this data in frequency distribution. First, if I'm giving you specific classes, you have to use them. If I'm not giving you any classes, then you have to construct the classes by yourself. So first, how I can construct the classes? If you can refer back to the last lecture, I'm giving you in details how to construct the frequency distribution for the quantitative data into 4 or 5 steps. Step 1, you have to find the number of classes. Step 2, you have to find the class limits. Step 3, you have to find the limits itself, and then you have to 4 and 5 you count and put the frequency in each class. So now start with the step 1. So assuming يبقى هجاوب على السؤال ده الاول بافتراض ان انا مش مديك الكلاسز، وبعدين رقم 2 هجاوب عليه مره ثانيه بالكلاسز اللي انا مديها لك، لانه الحقيقه ممكن في السؤال انا اديك الكلاسز واوفر عليك الوقت، او ان انا اطلب منك تعمل كونستراكت للفريكونسي تيبل. في المحاضرة السابقة اللي أنا شرحت فيها يعني إيه frequency distribution، شرحت بالتفصيل how to construct the frequency distribution. هطبق ده سريعا معاكم، يعني مش هاخد مننا 2 minutes. step 1 قلنا step 1 لازم تحدد ال number of classes وسميناها ال k. how to find؟ قلنا 2 to power k has to be greater than n. وال n the number of values that we have. هنا ال n عندنا equal كام؟ equal 30. يبقى I need to find the value of k that give you 2 to power k greater than 30. Okay? طبعا 2 to power k greater than 30 you can use a calculator for that، لكن I think you'll find 2 to power k greater than 30 very simply if you are putting ال k before. لا طبعا trial and error you can find that or using calculator. يعني 2 to power 3 equal 8. 2 to power 4 equal 2 to power 4 equal 16. 2 to power 5 that greater than equal 32. So that greater than. Okay, so trial and error you'll find the value of k equal 5. Why? Because 2 to power k, 2 to power 5 that equal 32 that greater than 30. So now step 1, what is the number of classes that you have? From that we can say we have a k equal 5. Even number of classes in that it will be 5. That is step 1. Step 2, you have to find the limits. Sorry, you have to find a class width or length. Okay, that's step 2. يبقى step 1 بنجيب عدد الكلاسز او الانترفلز. step 2 هنجيب طول الايه الفتره او الكلاس. يبقى اللينث الويدث قلنا equal الهايست فاليو minus الماكسيمم minus المينيمم، الهايست فاليو minus lowest value, all that divided by k. So in our case, look at your data. What is the maximum value from that table? 35. What is the minimum value in that table? Equal 21. How many classes you have? We have 5. So that indeed approximated equal 3. Approximated, because 14 over 5, that will give you almost 2.8. 2.8 can be approximated to be 3. So now length or width for the class equal 3. So I have 5 classes and the length for that class equal 3. Now step 3, I need to find the class limits. So the first class, the minimum equal 21. So now first class it will be 21. 2 plus 3 it will be 24. That's the first class. يبقى first class limits 21 ده minimum plus length width or length 3 يبقى 21 plus 3 equal 24. يبقى from 21 to 4 that's the first class. The second class in the same value from 24 to, but actually how to read it? From 21 to less than 24 or up to. يعني 24 now included in the second interval or in the second class, not in the first. So 21 to less than 24, 24 to less than 24 plus 3 that equal 27. So now each time I'm adding a width or a length which is 3. يبقى starting from the minimum value 21 and then add 3, then it will be 2 less than 24, and then 24 2 less than 27, and then 27 2 less than, that is third, 27 2 less than 30, and then 32 less than 33. I need 5 classes, okay? That's the fourth one. The last class from 33 to less than 35. Sorry, 36, because 33 plus 3. Okay, but the last class you can close it actually. Okay, so in the last class you don't need to say less than, because that last class you can make it close the class. Okay, so that class 1, class 2, 3, 4, 5, and now I have 5 classes. So step 1, find the number of classes. Step 2, find the class width or length. maximum minus minimum divided by number of classes, approximate that for convenient number. Okay, so I prefer to have integer value or any convenient number in that case. So that's the classes that we have. That's step 3. Step 4 and 5, you construct the frequency table. Just for each class, you can count how many values you have. So now just you can use these classes to construct the frequency table. Okay, so so not undo. So in that case, just very simply, you can add now step 4 and 5, you can find the frequency table, so that in the classes that you have, you can write a class or interval. Okay, that in first column. Second column, you can add now the frequency values for that. So that how, and then you can count how many values in each class. I will do that with you now actually, and find a total for that has to be a total equal number of values that you have in your table. So in your table you have 30 values, then has to be total equal 30 values. So that how to construct the frequency table if I'm not giving you the classes. Now just count how many values in that table from 21 to 24. Just we can find the first one, and please you can continue. So I need to count how many: 21, 22, 23, and not including 24. Please be careful about that. So 21, so can change the color. So that 21 and 22 and 3, and we have 23, another 2 values. Okay, so that 21, we don't have any values in that one. We don't have any values. We have 3 values here. We have nothing here. We have nothing here. We have a 23 one here. So that all the values. Now 1, 2, 3, 4, 5, 6, 7. So I have 7 values for a range from 21 to less than 24. Just write the frequency equal value 7. You can do that for the other classes. You'll find second class you have the frequency equal 4. The third you have a 9. The fourth you have a 4. The last one you have a value 6. And then sum of these values equal 30. So that now we answer now question A, how to construct the frequency distribution. So that if I'm not giving you the classes, if I'm giving you the classes, directly you can use them. Okay, you don't need to have all these steps. Just you can construct the frequency distribution using the classes. So the same classes actually, so they are constructing. So now you can see, so I'm following the same steps. Yeah, we find I have the same classes that we have. Even if they are different, okay, you can use them. يعني عايز اقول بشكل مختصر، لو الكلاسز given استخدمها على طول وconstruct the frequency table. لو they are not given for you هتعملهم بنفسك بالستابس اللي انا شرحتها بالتفصيل دلوقتي. نجيب الاول number of classes، بعدين الويدث او length للكلاس، then find the class limits, and then construct a frequency for each class. I'll find the frequency for each class, then you have the frequency table. Now we answered the question A. A question B, the same as a question B for the qualitative data. We need to find the relative frequency and the percentage frequency in the same way. For each frequency divided by total give you relative, and relative times 100, that will give you actually the percent. يعني we don't need to waste time in that. يعني بنفس الطريقة اللي حسبنا بيها relative frequency في حالة ال qualitative data هنحسب ال relative frequency. يعني 7 over 30 give you the value, 4 over 30 give you the value, and then times 100 will find the percent frequency. And that now you have the frequency to answer questions like how many, relative frequency to answer questions like what is the probability, and percent frequency to answer questions like what is the percent of. Okay, يعني لو في سؤال عايز فيه عدد تستخدم الفريكونسي، سؤال بيسأل على البروبابيلتي او الاحتمال تستخدم الريلاتيف فريكونسي والبرسنت فريكونسي على حسب السؤال. In the same برضو نفس الكلام الريلاتيف فريكونسي والبرسنت فريكونسي introducing the same information but in different forms. يعني different forms ده بدل ما الارقام as ratio from 0 to 1, I'm presenting that as out of 100 in percentage. Okay, في المية بدل ما أقول من المية. That now we answer the question B. Direct application for relative frequency and percentage frequency to answer the questions. That in C. Yeah, but question C ask you for what percentage of days is the number of computer produced in the interval أو the class 27 to 29. Be careful now. 27 to 29 the same as 27 to less than 30. يعني you can read that as 27 to less than 30. Okay, the same way. So what percentage of days you have in production computer produced between 27 to less than 30? Just you can find that from actually the class that you have, that 27 to less than 30, and then you'll find the percent equal 30%. And the same as the qualitative data, I can ask you many questions, okay, using how many, what is the probability. So now if I can ask you, what is the probability to have computers, what is the probability to have the production of computers at least 27? What is the probability to have the production of computers at least 27? ما هو احتمال يكون إنتاج الكمبيوترز على الأقل 27 كمبيوتر؟ عشان تجاوب على السؤال ده أنا بقول لك at least 27، يعني معناها 27 فأعلى، يعني including the 3 intervals دول، وأنا بسأل what is the probability، يبقى we have to use this one. يعني الأنسر هتبقى 0.3 plus 0.133 plus 0.2، يعني almost equal كام؟ equal 0.63. يبقى that's how to answer. You have to be careful about how to answer questions like at least, at most, between, less than, greater than. Please be careful about that. Okay? So the same as the questions for the probability, we can use the same tricks in that case. Okay, so that question C, how we can use a table to answer the questions. Question D, I need to visualize the quantitative data and the frequency distribution in some graphs. We have some graphs actually, mainly we have a histogram and we have a polygon. So the histogram the same as the bar chart, and the polygon that mostly straight line crossing the midpoints for the histogram. So I will start with the histogram and then I will introduce a polygon, so that it will be the actually at the end that will be the graph, but I need to introduce that in different manually. We can do that step by step. يعني نرسم مع بعض الرسمة بالتفصيل مع بعض زي ما رسمنا مع بعض من شوية الايه البار تشارت. نرسم مع بعض كده الهيستوجرام. يبقى first I need the x axis, so that I'm trying to make it a straight line. So that will be the x axis and that will be the y axis. Okay, so the x axis for the classes, well, y axis will be for the frequency values. I will present first the histogram, then I will present the polygon. So put the classes, these two lines means I will not start from 0 for the x-axis, so that the classes, the first one from try to have equal distance, that 21 to 24, and then 24 to 27, trying to have equal distance, and then 27 to 30, and 30 to 33, and then 36 last value. So that's the classes that we have, and we don't have now separate between the classes. You have all that as intervals. Okay, that's the quantitative data. Now for the frequency, I need to plot the frequency values on the y-axis. So please fix the scale of the y-axis. How to fix that? Look at the frequency value that you have. Minimum value equal 4, maximum value equal 9. Then you can fix the scale as 2 by 2 or 1 by 1 as you like. We can do that as 1 by 1. So that assuming that's 0. So that will be 1, that 2, that will value 3. I'm trying to make equal distance, but that actually it will be, I need to make it short. So that will be the value 3, that will value 4, that will value 5, will value 6, 7, 8, last value 9. Okay, so that's the frequency values, and that the classes that we have. So now for the first class from 21 to 24, we have the frequency equal 7. So try to have one bar. Still we have bars, the histogram as bars. For each class you have one bar. The height for that equal the frequency value. So I'm trying to be accurate for that. No. Okay. So that's for 7. That is the first class. The second class 4. There is no gap between the bars. So that the second class almost for value 4. So that's second. Third 9. That the highest frequency. Almost that. And then 9. And then we have 4 for the 30 to 33 class. We have 4. So I'm trying to, and the last one till value 6. So actually that has to be till value 6. I'm trying to make that accurate way. Okay. Okay. So that the distribution. So that we name it as a histogram. So that the histogram for the values of the daily production of computers. What you can observe from that graph. We can observe that the highest frequency for the interval or the class from 27 to 30. That means most of the days we have a daily production of computers. It will be between 27 to less than 30. Okay, so the histogram giving you idea about the distribution of the data that you have. So we have different idea how we can use the histogram, but anyway now I need to finalize that question and I will return back for the discussion how we can use the frequency, how we can use the histogram to explain the distribution of the data that you have. But now the highest frequency at the middle level. So assuming a low level from 21 to 24, well, highest level from 33 to 36, and the middle level almost to 27 to 30. Then you have the highest frequency at the medium or moderate level for that variable. So medium level, that the medium level has highest frequency. So the highest frequency at the medium level for that variable. So in that case, we say we have symmetric distribution. I will return back for that point. Anyway, that's the histogram. What is the polygon? A polygon mostly over, you can put that over a histogram. So now assuming that the midpoints, so in each class, that the midpoint, the value in the middle, I mean, we name that as a midpoint, approximated. In the before the first class, assuming you have another class, and that will be midpoint for that. And for the last class, assuming you have another class, and that most it will be midpoint as a starting and ending. Okay, and now a straight line crossing these. Sorry, I need to make a straight line. So a straight line crossing these midpoints, we name it as a polygon. But the straight line crossing the midpoints of the histogram classes, we name that a polygon. So the histogram and the polygon almost introducing the same information but in different way. In histogram, you have bars for each, you have one bar for each level, and that giving you idea about the distribution of the data. And the polygon, a straight line crossing the midpoints, is still introducing and giving you idea about the distribution for your data. Okay? يعني عايز اقول ان الهيستوجرام والبوليجون الاثنين بيقدموا نفس المعلومه لكن الحقيقه بشكل مختلف، اما باستخدام البارز فبنسميه الهيستوجرام او باستخدام straight line crossing the midpoints for the class that you have، وده بنسميه هنا الايه البوليجون. طيب هرجع للبوينت دي بالتفصيل. الهيستوجرام هيساعدني في ايه؟ how to know distribution of your data. الحقيقه ده مهم جدا. يبقى احنا كده بشكل مختصر شرحنا بالتفصيل how to present the quantitative data in frequency distribution, how to construct the classes, and then how to find relative frequency and percent frequency, how to answer the questions based on the frequency table and relative frequency and percent frequency, and how to present your data in histogram and polygon. Okay, that is very important actually. في another example, that example 2, في example 3, you have an answer. I will leave it for you actually. So now we can look at that, the same graph that we have, okay, the same histogram and the same polygon. Example 3, I have the answer for that, but I will leave it for you the same. So for that, assuming that the number of students in 40 schools, okay, and now we have the values. So I will leave that for you, but you'll find the answer. You have the frequency table, percent of frequency, I have a histogram, and all the answer that you need, you'll find it given for you. Now I need to finalize my lecture by the discussion about how I can use the histograms actually to present the distribution of your data. So now look at these 4 graphs. So each one of these that histogram, so graph 1, graph 2, 3, and 4. So now what is the difference between 1 and 2 and 3? So in the first graph, we name it as skewed to the right. Why skewed to the right? Because it tailed to the right in that graph. In that graph, you'll find, assuming a minimum value 0, with maximum value 100 in each graph of them, assuming that. So that's 0, and that 100, and that 0, and that 100, and so on. Assuming for all these 4 graphs, you have a minimum is 0, with maximum is 100. What you can observe, in the first graph is skewed to the right, the distribution of the data that you have, you can observe that the highest frequency for the values at the low level, so almost the highest frequency around the value 20, assuming that approximated. So if you have the data skewed to the right, that means the distribution of your data, you have the highest frequency for the low values, and you have the small frequency or the lowest frequency or the minimum frequency for the highest values. So if you have your data skewed to the right, that means the highest values, or sorry, the highest frequency for the low values in your data. The opposite side, if you have the data skewed to the left, it tail to the left, then you say it's skewed to the left. So now in that data, almost you'll find the highest frequency for the high values, assuming that around the 80. How many values? Most of the frequency values for the low values around 20. In that graph, the highest frequency for the values around 80. So skewed to the right, that means most of the values are high values, and skewed to the right means most of the values are small or low values. Now the optimal situations in some cases to find that symmetric distribution. Symmetric means you have the highest frequency at the middle level, assuming that around the middle around 50. So now what you can observe, you have small values that they have small values. You have a few values, they have small values in that case, and you have a few values, they have high values in that case, and then you have most of the values at the medium level. So very simply, the comparison between these 3 graphs, it's very important to give you an idea about how the histogram present a distribution. Skewed to the right, then most of the values at the low level. Skewed to the left, most of the values at the high level. Symmetric, most of the values at the medium level for that variable. Sometimes you have symmetric data, but they have 2 centers. So that if you have different groups in your data, and then you can find for each group you have 1 center. So then in that case we say you have symmetric data, but you have different centers in your data. Symmetric, yes, but you have different centers. For each group you have 1 center. So that's one of the main questions can be saying that if you have a skewed to the right data, then most of the values at the low level, true or false. If you have symmetric data, most of the values at the medium level. That's one of the main points, how we can use the frequency, how we can use actually the histograms to present the distribution of the data. Okay, so now I finalized the applications to how to describe your data in frequency tables and graphs. In the lecture notes that I will upload that for you, actually, you'll find some problems in the same way. Please try to answer these. So problem 1, giving you some numbers about the bedrooms, and then for 30, they have 30 values, and then we need to find the frequency distribution and so on. So now what you can observe, for these values, a few values, then we can construct for the frequency table similar to the qualitative data. But for the other questions, so that one is a qualitative data. Problem 2 is a qualitative data. Problem 3, I'm giving you actually the frequency distribution, and then all the questions based on that frequency distribution. So you can expect in some questions you have the frequency table or frequency distribution, and just you can use it to answer some questions. Last problem, problem 4, I'm giving you the quantitative data, and you have a classes, and then you have to construct the frequency distribution and then find the relative frequency and so on based on that. So please try to solve these 4 problems to have the full understanding of how to describe your data in frequency tables and graphs. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.